Yes, good morning, friends. Welcome to the session once again. I hope you all are doing good. How is your preparations going on? So, today is the second session under our climatology. Yesterday, we have taken up the first session. Today, we will continue with the second session. Okay. In today's session, we will discuss from the point that we have left yesterday. Yesterday, we have discussed the basic characteristics of the atmosphere. Under the chapter of this climatology, as you know, okay, under this chapter of climatology, the basic component of the study is the atmosphere which is surrounding us. Therefore, as framing the topic, yesterday we have seen the basic characteristics of the atmosphere, that is different structure of the atmosphere, that is stratosphere, troposphere, stratosphere, mesosphere, thermosphere, and also the important composition of the atmosphere. Certain gases, certain water vapors, certain particulate matters. What are the function of all those particular matter? Say for example, CO2, carbon dioxide, it is a greenhouse gas. It is responsible for heating the earth. What is the function of water vapor? Again, it captures the long wave, re-radiated wave. Also, water vapor helps in the transfer of heat from one region to the other by the process of latent heat. Also, we have seen the function that is performed by particulate matter in the cloud formation. Why? Because the particulate matter act as a nuclei. So yesterday we have seen the basic structure of the atmosphere, and also at the same time temperature characteristics and also different composition of the atmosphere. Clear? So today we will continue from where we have left yesterday. Today we will see the temperature characteristics or sun's insolation characteristics if you go from one part of the earth's surface to the other part, or you can say from one latitude to the other. Okay, good morning friends once again. Shall we begin the discussion? See, before I start, let me tell you one thing. In the middle of the discussion, if you have any doubt regarding any point, you kindly interrupt me in the chat box below and you can ask me. Okay, anyways, before we go into the session, I just have one information to share, that is your prelims 2022 prelims is on 5th June 2022. Okay, so just around 6 months left. Taking that into consideration, from the Unacademy platform, we have started a comprehensive course for 2022 as well as 2023, but especially for the 2022. Okay, so it has started from 1st of December, but you can always chip in now also. It will cover comprehensive course so that before your prelims exam, you are well thorough with the entire syllabus. Similarly, in your roadmap, if you are planning to sit for the exam in 2023, you can always go for this 2-year batch. Okay, so the timeline, you can follow your own timeline accordingly. You see here, mains is 16 September 2022. For 2023, prelims is expected in the month of May or June 2023. Mains is September 2023. Okay, you also have this test series in Unacademy platform. One is the Unacademy Compact, which happens every Sunday at 11 a.m. It is available both in English as well as Hindi. Along with this, we have T20 current affairs. 15 MCQ, 15 minutes. The MCQ is relating to the current affairs. It is also available both in Hindi as well as in English, Monday to Friday, 7:30 p.m. You have this Abhiyan, that is which deals with the static portion. Say for example, in your polity, in your geography, in your economic, there are certain concepts. Those are static. The basic foundational core understanding of the subject will be asked or will be tested in this Abhiyan test series. It is also available both in English and Hindi, Monday to Friday, 10 a.m. For all of this, you can use my code, that is SUNEP10. Okay. Chalo, we'll go ahead with our discussion today. Also, and kindly, you also have 20 GS book, which is written, curated by top Unacademy educator in the platform. While preparing this book, the syllabus and the letters and the previous year question paper, taking this into consideration, the book has been written. So once you catch whole of this 20 GS book, you don't have to go anywhere in search of any of the topics. All the topics point by point it is covered here, aligning with the latest trend which is evolving in the UPSC. And also it is reviewed by previous year UPSC topper also. Clear? For this you can also use my code SUNEP10. It is available both in English as well as in Hindi. Clear? Chalo, let us go ahead with our discussion. Okay. Remember, climatology is such a chapter which is very scoring. One very good thing about thing is it is very scoring. Second important point is, if you understand the concept or if you understand the basic principle of how climatology works, okay, you don't have anything to remember. There is very less thing that you need memorization. Otherwise, understanding based chapter, this climatology, very scoring and very relevant in day-to-day life as well as your exam. Okay. So yesterday we have seen the basic structure of the atmosphere, that is different layers, and also we have seen different composition of the atmosphere. Okay. Consisting of different gases, water vapor, particulate matter, so on and so forth. We have seen the function also. Today let us see the factors affecting the distribution of insolation. What is this insolation? This insolation is the sun insolation. Now, the earth is sphere. Now, the sun insolation which reaches the earth's surface is not uniform. In certain region, the sun insolation is very high. In certain region, the sun insolation is very less. That is the intensity. The intensity of insolation. That is one. The intensity of the sun insolation varies from place to place. Number two, the duration of the sun insolation. Duration. In certain places, say for example, right at the polar location, if there is a, during summer season, in the northern hemisphere, if there is a sun insolation, it is there for months and months. In the winter, it is darkness for months and months. In the tropical region also, say for example India, during summer we have more hours of daylight, less hours of night time. Okay, but only in the equatorial region you will have somewhere around 12 hours daylight, 12 hours night time. So the duration is also different in different region of the world. Now, since the sun is the ultimate source of energy for the earth, different climatic phenomena, weather conditions is determined by the sun insolation. Therefore, it is very important to know the intensity and duration of the sun insolation. If we understand sun intensity and duration, it will be very easy for us to know about its implications regarding different climatic and weather phenomena. Say for example, let me tell you, the wind system is also because of sun insolation, I can say, in a way. Why? Because when there is a high sun insolation, the air becomes light. When the air becomes light, it goes up, which means creating a low pressure here. So from the surrounding high pressure region, wind blows like this. So the sun insolation, its intensity, duration across the globe is very important. Therefore, the factor that is affecting distribution of sun insolation is number one, the angle of the sun's ray. Now you see here, this is one simple example. You see here, here in the equatorial region, okay, this is just an example. The sun insolation is coming vertically. Say for example, it is 90 degree like this. Okay, kindly follow the pointer. The sun insolation is coming, hitting the earth's surface in the equator at 90 degree like this. Okay, now it is covering a small area. Okay, this is a small area on the earth's surface, but the intensity of the sun insolation will be concentrated in a smaller area, so the intensity will be very high. On the other hand, since by the virtue of earth being a sphere, the sun insolation which is reaching the higher latitudes is slanting, it is diffuse. You see here, the sun insolation is getting diffuse, covering a larger area, but here the intensity of the insolation will be less. Therefore, even if it is covering a lot of area, intensity will be less. So that is one of the factor of determining the sun's intensity on the Earth's surface. So the factors that is affecting the distribution of insolation is sun insolation will be more towards the equatorial region. The sun intensity will be less away from the equatorial region. Yes, see, sun is here. We all know that the sun relative position regarding the earth is constant. But we used to say that the sun apparent shift towards the north and towards the south. The apparent shifting of the sun insolation is because of the tiltedness of the earth's axis. Earth has two basic motion. One is it rotates around its own axis in a tilted form. The other is it revolves around the sun. Because of the tilted axis of rotation, there is an apparent shifting of the sun insolation north and south depending on the season. Clear? But whatever the apparent shifting to the north and south it may be, the sun insolation is always more towards the equatorial region or equatorial region and in and around the equatorial region. The moment you go away from equatorial region, the intensity of the sun insolation will decrease. Why? Because the sun insolation, when it falls to the earth's surface, will be diffuse. So will cover more area, but less intense insolation will happen. Clear? Now that is one. The second is duration. Okay, sun insolation, one is the intensity. The intensity of the sun insolation, just now we have seen it is because of the angle that is met by the sun insolation on the earth's surface. The second is the length of the day will also determine the sun insolation on the earth's surface. I have already mentioned to you just now the importance of this sun's insolation. Importance is, you see, sun insolation is very, very important for many climatic and weather phenomena, which is the subject matter that we are going to study under this climatology. So it is very, very important to know the nature of sun insolation. So for the duration of sun insolation, you see here. Okay, kindly follow the pointer. You see here. This is how. This is sun. This is earth. This is how the motion takes place. But the motion of the earth, which revolves around the sun, is rotating. The earth itself is rotating at a tilted axis like this. Therefore, from the sun, when it falls down to the earth's surface, it is lighting up not complete one part of the earth with respect to the axis. See, earth is a sphere. So in whatever orientation you keep the earth, exactly half portion will come under the sun insolation. Exactly half will be away. But with respect to the axis, you see here, this axis, it is not complete half of the axis, but a part of it will be light up like this, depending on it, depending on the position of the earth. Okay, this diagram refers to this one. See, here the northern hemisphere is having a summer. This position is known as summer solstice. That is because of the apparent shifting of the sun insolation, because of the tiltedness of the earth. Here the sun insolation is falling at Tropic of Cancer, 90 degree at Tropic of Cancer like this. When the sun insolation is falling 90 degree to the Tropic of Cancer, this is a Tropic of Cancer line. It is a summer solstice. During this time, the northern hemisphere will have summer season. At this particular period of a time, you see here, entire region above the Arctic Circle is completely under the sunlight. And this particular region experiences months and months of sunlight. Okay, theoretically you can say 6 months of sunlight. Clear? Clear? So the duration, now if you see here, the duration of sun insolation will be maximum at this polar location. If you come down, it will gradually reduce it will gradually reduce, and if you come to this location, it will be complete darkness all throughout the 24 hours. So for months and months, this location will be under darkness, means the duration of the sunlight is changing. Now, if I change the position completely again to this, when the northern hemisphere is undergoing a winter condition, in the southern hemisphere, you see here, the situation is completely reversed. This northern hemisphere, the North Pole, Arctic Circle and above towards the North Pole will have around 6 months of darkness, no light at all. At these two particular location, which is known as equinox, equinox is a condition or a situation when the sun insolation is 90 degree at the equator. Okay, summer solstice is when the sun insolation is 90 degree over Tropic of Cancer. Winter solstice is when the sun insolation is 90 degree over Tropic of Capricorn. Autumnal equinox is when the sun insolation is 90 degree with respect to the equator. Okay, and vernal equinox is also when the sun insolation is 90 degree with respect to the equator. Clear? So accordingly, the duration of the insolation is also determined. So see, why this duration of the sun insolation and how it is determined? Because of the rotation of the earth around its own axis in a tilted axis, in a tilted form. That is one. The second is revolution of the sun, earth around the sun. I'll just give you one example. Say for example, instead of this tiltedness, if the earth is rotating around its own axis on a completely non-tilted axis like this, vertical axis like this, then there wouldn't be any kind of duration, difference in the duration of sun's insolation. Okay, completely half part of the world will receive sunlight 12 hours, another 12 hours you will be having darkness. So there won't be any kind of variation in the duration of the sunlight. But since the earth is rotating in a tilted axis, the duration of the insolation is different in different location of the earth's surface. Clear? That is the second factor. The third factor is distance between the earth and the sun. That is third important factor for the sun insolation. You see here. Kindly go through the diagram. It is very, very important. Try to find this aphelion and perihelion. What is perihelion? What is aphelion? Perihelion is a location when the earth is nearest to the sun. See, when the earth revolves around the sun, it is following an elliptical path. In any kind of elliptical path, there are two locations. That is, one is the nearest and the other is the furthest. So the nearest point of the earth with respect to the sun, it is known as perihelion. And the furthest point of the earth from the sun is aphelion. Now, what is the significance of this? You see here, during perihelion, that is when the earth is nearest to the sun, perihelion, the northern hemisphere experiences winter. Okay, remember this. The northern hemisphere experiences winter when the earth is nearest to the sun. Okay, now, and this is because of the tiltedness, the orientation of its tiltedness, because of that reason. Now you see, what is the implication? Implication of the distance from the sun. You see here, the winter in the northern hemisphere would have been very, very intense. Okay, see, the winter that we are experiencing in the northern hemisphere, it would have been much, much cooler. Okay, much, much cooler. Say for example, even to an extent of middle latitude, there would have been, freezing that would have been taken place. Okay, very cold wave, and even habitation beyond around 40 to 45 degree north latitude would not have been possible at all. Why? Because the northern hemisphere would have been very, very cold. But because since the winter in the northern hemisphere happens when the sun is nearest to the earth, the winter in the northern hemisphere is reduced. The intensity or the intenseness of the winter is reduced in the northern hemisphere. Clear? That is the implication of sun insolation vis-a-vis the earth's surface. On the other hand, you see, when in this perihelion, when the earth is nearest to the sun, the southern hemisphere is having a summer. Therefore, the summer in the southern hemisphere as compared to the northern hemisphere is more intense, because the summer in the southern hemisphere occurs when the earth is nearest to the sun. That is the implication, or that is the effect of distance between the earth and the sun and influencing the insolation of the earth's surface, of the sun insolation. I hope that is clear. Then comes the fourth, that is the effect of atmosphere. What is the effect of atmosphere in the sun insolation? See, yesterday we have seen the different composition of the atmosphere. Broadly, we have seen the composition of the atmosphere. What is this? Broadly, we can classify into gases. What are the other two? Particulate matter. The third one, water vapor. What is the function? Gases can be CO2, oxygen, nitrogen, argon, all those inert gases, particulate matter, and water vapor. Now, what are the function of this? And also we have seen 90% of the atmosphere, that is 90% of the composition of the atmosphere is found from the Earth's surface within 16 kilometers. From surface of the Earth within 16 kilometers you will find all of this, which means in the troposphere. We have seen the function. What is the function of CO2? The sun insolation, when it comes hit the Earth's surface, the short wave sun insolation get reflected and goes in the form of a long wave. This is captured by this CO2 and responsible for heating. That's why CO2 is known as greenhouse gas. Similarly, you have water vapor. It also captures the long wave re-radiated radiation from the Earth's surface. It is heating up this. So the presence or absence of such kind of a material will determine the effectiveness of the sun insolation. Yes, the sun insolation is coming from above, but the heating of the Earth atmosphere is from below. Therefore, hypothetically, let me just give you one example. If there is no CO2 or water vapor, then whatever the sun insolation will be there will be reflected back. Once it is reflected back, the Earth would have been very, very cold. So it is the function of this. That is the effect of the atmosphere vis-a-vis the sun insolation. I hope that is clear. Now, depending on all the points that we have discussed so far, that is the angle of the sun insolation, the duration of the sun insolation, and also the distance from the sun, relative distance of the Earth from the sun, and also the effect of the atmosphere. This is the distribution. The graph which is in front of you displays the distribution of insolation on the Earth surface. Very, very important diagram. If you understand this, then you understand the insolation on the Earth's surface completely, and by understanding this you will be able to correlate many important weather and climatic phenomena. When I talk about weather and climatic phenomena, it can be a cyclonic circulation, it can be a ocean current, it can be a different planetary winds, secondary winds, local winds. You will understand. Clear? Chalo. Kindly go through this particular graph. Very, very important. This horizontal axis is a month, that is January, Feb, March, April, so on and so forth. These different colors represents different latitude. This blue color represents the sun insolation in the equatorial region, 0. This particular green represent at 30 degree north latitude. This red color represents 60 degree north latitude. Yellow color represents 90 degree north latitude. Similar thing will be replicated for the southern hemisphere also, but just we will consider this northern hemisphere. Okay, so kindly go through, and as I have already shown you what is this equinox: March equinox, September equinox, okay, June solstice, that is the summer solstice, winter solstice. What is this solstice? We have already seen. Okay, so you correlate the months, you correlate different latitudes, you correlate different equinox and solstice, and try to analyze this particular graph. Very, very important. Kindly do so. You start from the equator, and remember the vertical axis or the y-axis represents this sun's insolation intensity. Okay, sun insolation intensity. Yes, kindly go through. See, let us begin with equator. See, we know the actual distance of the sun and earth is fixed, or the sun location is fixed. Sorry, I stand corrected. The sun position is fixed, but because of the tiltedness of the earth's rotation axis, we say there is apparent shifting of the sun insolation vis-a-vis different latitude. But whatever the apparent shifting may be, the sun insolation is always almost vertical to the equator. And also in 1 year period, exactly vertical, like 90 degree, sun's insolation 90 degree with respect to the equator happened twice. Once while going up towards the Tropic of Cancer in the form of summer solstice during the northern hemisphere summer, one while coming down to the southern hemisphere for the winter solstice, it also crosses the equator, so another 90 degree. So as we know, as we have discussed just now, whenever sun insolation is directly 90 degree over any place, it will have maximum intensity of insolation. And another point regarding this equatorial region is, whatever the apparent shifting of the sun insolation it may be, it always remains almost vertical to the equatorial or near the equatorial region. Therefore, you see here, this represents the two peak. See, this blue color is at equator. So, this in equinox time, March equinox maximum, September equinox maximum, but even the minimum, okay, this is in the equatorial region. Sun intensity of sun insolation in the equatorial region, it is almost fixed. It doesn't change much. Yes, there are two peaks is there during the equinox, but the intensity almost remains constant in the equatorial region. Clear? Now you go to higher latitude now, 30 degree. Let us assume this to be a Tropic of Cancer. Now you see here, in this you see, in the winter season, when the sun is in the southern hemisphere, over the southern hemisphere, because of the apparent shifting, the sun insolation intensity, it will be more slanting. Okay, more slanting means more diffuse. Say when the sun is towards this one, it will have more slanting or diffuse. The angle is less. Therefore, intensity will be less in the northern hemisphere. Therefore, I start with this. Gradually, it will increase when the sun again goes towards the northern hemisphere. Apparent shifting during the northern hemisphere summer, it will increase gradually. A time will come when it is completely at 90 degree with respect to the Tropic of Cancer. So during that time, it will have maximum. And since the sun insolation makes 90 degree with the Tropic of Cancer only once in a year, it is having only one peak. And after this, when the sun insolation again comes down to the goes down below this Tropic of Cancer, again this intensity will come down gradually like this. Clear? Let us go to the next, that is 60 degree north. Okay, now this one you see here. Now here the insolation, intensity of insolation is again very less. It is almost near to 0. Now this will also go, and when the sun comes to the northern hemisphere, it will also increase its intensity, but it is below this one. Okay, you see here, and again it will come down like this. Now let us go right at the polar location, that is 90 degree north. What is the behavior? You see here, this particular yellow line represents intensity of sun insolation right at the north pole. Now it is not, why this yellow line is not starting from somewhere here. See, other line like the equator started from here, 30 degrees started from here, okay, 60 degrees started from here. Yes, it is very less, very close to 0, but it started from this one. Why this particular yellow line starting abruptly from here, not from somewhere else here? Why? Because we have just seen right at the polar location, during winter season, insolation is 0. There is complete darkness for months and months. So there is no question about any intensity of insolation itself. Okay, therefore, it will start from this abruptly. Okay, now, when the sun insolation is coming towards the north, okay, north, see, it will also increase. It will increase in this manner. You see here, which one is the highest intensity here? This one. Why? Because at this polar location, for months and months, there will be insolation which will be coming. Clear? See, in equatorial region, it is almost, daytime is 12 hours, nighttime is 12 hours, almost, approximately, you can say. But in the polar region, when in the summer, there is continuously for months and months, there won't be any night. There won't be any dark. Months and months, there will be light. And during winter, months and months, there will be darkness. That's why in the polar region, the inhabitant of this polar region, they use, or in the higher latitude, okay, when you have this one, for many days or many weeks, when you have a sunlight, they use a very thick curtain in order to obstruct the sun's ray. Why? Because see, they just have to see the clock. They just have to see the watch. Otherwise, by the brightness and darkness, because there won't be any darkness, so how they will know that it is night time? Okay, so at night time, in order for them to sleep well, they use a thick curtain. Okay, so this particular graph is very important. It shows the entire distribution of insolation on the Earth's surface. Okay, chalo. Let us go to the next portion, that is distribution of temperature. You see here, insolation is one, temperature is another. Okay, insolation, temperature. Okay, insolation is sun's ray on the Earth's surface. Temperature is the actual temperature of any specific place over the Earth's surface. You see here, they are very similar, and they actually there is a lot of correlation between insolation and temperature, which we agree completely. Okay, and they will all follow the same line. Say for example, if the insolation is more, temperature will be more. If the insolation is less, temperature will be less. So they correlate. They can be, interchangeably used also, but we will analyze separately. Okay, so the first one we have seen just now, that is the insolation, that is sun's ray on the Earth's surface. Now we are going to see the distribution of temperature on the Earth's surface. Okay, distribution. Why? Because it will capture the temperature on the Earth's surface much better than the insolation. Why? Because see, let me give you one example. Okay, you see here, in the equatorial region, insolation on the plain region, insolation in the mountain. Say for example, there is a mountain in the equatorial region. The sun insolation per se will be same in the here and here also. Yes, there is some distance, but if we just ignore this one, as compared to the distance between the sun and the earth, if we just ignore this particular distance, what will happen is, you see, yeah, okay, what happened? Okay, so what will happen is the sun insolation will be similar in this particular equatorial region. But as far as the temperature is concerned, since temperature is also a function of altitude, that is, the more I go up, the temperature reduces, okay, because the heating is done from below. So the temperature will be different even if they are both in the equatorial region, okay, which means temperature distribution of temperature captures the different actual temperature on the earth's surface much better than the insolation. Okay, now distribution of temperature on the earth's surface latitude wise. So there is a positive correlation between insolation and temperature here, which means, you see here, the sun insolation in the equatorial region is maximum. The moment it goes to both the hemisphere, the insolation decreases. In general, we can take that as a rule. Now, therefore, temperature will be more in the equatorial region as compared to other latitude. So the maximum temperature you will find in the equatorial region as compared to other latitude. Least temperature you will find in the polar latitude. Okay, so temperature is a function of latitude. But there is some exception, that is, you see here. And that is why we are treating insolation and temperature separately. Okay, what is happening? Kindly, okay. Okay, you see here. That's why we are treating insolation and temperature separately. You see here. Latitude wise, maximum insolation at the equatorial region, so maximum temperature. But in the equatorial region, because of availability of the ocean or water bodies, evaporation is happening rapidly. When the evaporation is happening in the equatorial region, a cloud formation will be there. Whenever there is a cloud formation, what will happen? The sun insolation which is coming down, the cloud is reflecting also. Okay, therefore, the sun insolation is obstructed by a cloud. You can imagine that way. Therefore, the maximum temperature is not exactly at the equator, but a little bit away from the equatorial region in the northern hemisphere. Clear? That is the difference. That is why we are handling the insolation and temperature separately. Okay, as far as the insolation is concerned, it is maximum in the equatorial region. But in the equatorial region, right at the equatorial region, because of the formation of cloud, the sun insolation is reflected, or it is not allowed to pass through very efficiently. It is blocked. Therefore, maximum temperature you will observe a little bit away from the equatorial region. Clear? That is one. The second is distribution of temperature on the Earth's surface is a function of altitude. Altitude, in a sense, the more you go up, the higher you go away from the Earth's surface towards the outer space, the temperature reduces. Why? Because we have already seen yesterday, even though the sun insolation is coming from above, the heating of the Earth atmosphere takes place from below, which means the long wave, re-radiated sun insolation long wave, is captured by the carbon dioxide, that is the greenhouse gas, water vapor, and heats up. Now, we have seen just now 90% of the composition of the atmosphere, that is water vapor, gases, which is acting as a greenhouse gas in order to heat up the atmosphere, remains very close to the Earth's surface. So the moment you go up, the temperature will reduce. Why? Because the composition, the density of the air will become very, very thin above. Therefore, the heating agent, that is the CO2 or the water vapor, are very less. Therefore, temperature reduces the moment you go up. That is the second factor. The third factor is the prevailing wind. Prevailing wind, that is the wind system. Whenever a wind is blowing from one region to the other, it is carrying the local wind from one region to the other. If a wind is blowing from a very warm region, then the hot wind is carried from that region to the other. Similarly, ocean current. Okay, ocean current. You see here, ocean current carries ocean water from one region to the other. We can club this prevailing wind and ocean current. Whenever there is a wind which is blowing, it will over the water body, it will carry the water, top part of the water along with it. Now, influence of this ocean current in the distribution of temperature on the Earth's surface. You see here, let me give you one example. This is an Atlantic Ocean. Kindly follow the pointer. This is Atlantic Ocean. This is equatorial region. Okay, this is Atlantic Ocean. This is South Atlantic. This is North Atlantic Ocean. Now, in this region, you have this North equatorial current, ocean current. You have Gulf Stream. Now, this particular current or the water is moving from which place? From equatorial place, from equatorial region, which means it is having a higher temperature. Means I can say it is a warm ocean current. Now, this particular warm ocean current in the name of Gulf Stream reaches this particular higher latitude. Say for example, United Kingdom and western part of Europe. Now, this particular region, Western Europe or United Kingdom, as per the latitude, this particular region's temperature is much higher if I just compare the temperature of this particular latitude. Why? The reason is because of the warm ocean current reaching up to this place makes this particular region raises up the temperature of this particular region. Therefore, for example, if there is no warm ocean current like this, then the temperature of this region would have been much lower. Means lot of freezing would have been taken place here. But now they are enjoying a kind of a very moderate and very good temperature, pleasant temperature. The only reason is because of the presence of this warm ocean current. And what it is doing, it is distributing the temperature or influencing the temperature on the Earth's surface. Okay, so these are some of the important factors in distribution of temperature on the Earth's surface. Clear? And this is also another point that we are handling insolation and temperature separately. Clear? I hope that is clear. Anyways, we'll end the session here today. We will continue tomorrow with other factors. Okay, other factors like the nature of ground slope, nature of ground surface, distance from the coast, nature of the land and water, that is the specific hit. Okay, you can also go and read up so that it will be easier for you to understand. Okay, so we will continue tomorrow. Thank you all for your patience and cooperations. Have a nice day. We will meet again tomorrow at the same time, 11. Okay, this month I'll be taking 15 sessions, including today 2 session is already over. So remaining 13 session. I am planning to cover climatology as well as oceanography. Let us see. Okay, bye bye and take care.